So after the successful completion of Apollo 10, which did, by the way, splash down on May 26, 1969, it was time to move into the final phase of preparations for the lunar landing itself, Apollo 11. The crew for that mission had been announced in January. They were all Gemini veterans: Neil Armstrong, the commander, Mike Collins, the command module pilot, and Buzz Aldrin, the lunar module pilot. And they had been preparing very intensely since that time, since early in the year, with only 7 months to go until they were going to fly. They had probably the toughest training burden of any Apollo crew. They had the least time to prepare for the biggest challenge, that being the actual lunar landing itself, that any crew had had up to that point. Now, they were certainly conscious, Armstrong and Aldrin were certainly conscious of the need to develop techniques for the moonwalk itself. And here you see Armstrong practicing scooping up the first sample of moon rock and moon dust using a specially designed scoop. This was called the contingency sample, and it was an idea that if something went wrong early in the moonwalk, before they'd actually been able to collect a good assortment of moon rocks, they would still have some small sample to bring home for the scientists on Earth if they had to leave the moon in a hurry. So the engineers designed a special scoop with a long handle that would actually fold up and fit into a pocket on Armstrong's spacesuit. And shortly after he set foot on the moon, he would pull out this handle and put it together and scoop up this quick sample, and then it would be in his pocket for the rest of the moonwalk. When it was time to come home, he'd have it. But, the moonwalk itself really was not the difficult part of Apollo 11. Even though it did take practice and they had to learn how to use these tools and to place experiments on the surface, that sort of thing, the real challenge of Apollo 11 was the landing itself. And this is a diagram that shows the phases of the final descent. Now, you remember that Apollo 10 practiced everything down to 50,000 feet. Well, that's the point at which the final descent to the moon would begin. Armstrong and Aldrin would be in the lunar module, oriented with their engine pointing in the direction that they were flying. And they would fire that engine again. They would light up that descent engine, and it would continue to fire until they were down safely on the moon. Now, the thing you have to remember about the lunar module is that it only had enough fuel for one try at a landing. So everything had to be figured out very precisely. They designed the flight path down to the moon to use the minimum amount of fuel possible. But you can see that this entire landing phase, which lasts about 11.5 minutes, so only 11.5 minutes to go from 50,000 feet and a speed of about 3,000 miles an hour down to landing on the surface, that took about 11.5 minutes if everything went well. And at an altitude of about 39,000 feet, they would start getting readings on their altitude from the lunar lander's radar. And that radar was a very important piece of data that would be fed into the onboard computer. And in fact, the computer was the only way that you could land on the moon without running out of fuel. The computer was programmed to adjust the amount of fuel so that they would have just the right amount of thrust on the engine. It was adjusting the thrust of the engine so that they would use just the right amount of fuel to make it down safely. The computer was analyzing the data from the landing radar, which would reveal not only the height above the moon, but the rate of descent. And then at an altitude of about 7,000 feet, a little more than 7,000 feet above the moon, the computer would pitch the lunar module forward, and not into a vertical position, but in sort of a slanted position so that Armstrong could now look out the window and see the terrain ahead and make sure that they were going to come down in a safe area. Now, we'll talk a little bit more about that in a second. Then finally, at about 500 feet, the lunar module would be in its final phase of descent, and for the last 100 feet or so would be in a nearly vertical descent. And assuming everything went well, as I say, 11 and a half minutes after engine ignition at 50,000 feet, they would be on the surface. Well, the computer was, as I say, essential to the landing process. And one of the ways that Armstrong would be relying on the computer was to show him where, in fact, they were headed for a landing. There was a special grid on the left-hand window of the lunar module, and you can see that grid on the left. There are in fact two panes of glass. There's an inner pane and an outer pane. Both of them have this grid pattern imprinted on them. You would look through that grid and line yourself up so that they overlapped, so that there was no disparity between the grid on the inner pane and the outer pane. And that way you knew that you were looking at just the right angle through the window. So the commander would look through the window, and by looking down at a particular number on that grid, by looking past a particular number that was supplied by the computer, Armstrong would be able to see where the computer was aiming them. So that was called the landing point designator. That number would come, as I say, from the computer. It would be updated by the computer as the descent progressed. And on the right, you can see an image of what that computer display would look like. It had various alarm signals on the left and various status lights. And on the right was the actual data numbers of the computer. You can see them kind of glowing light green. And at the bottom were the keypads that you would enter commands and data into the computer. That would be operated by Buzz Aldrin during the descent. He would get that information from the computer and relay it to Armstrong by voice during the descent. And then in the middle, you can see the sketch of Armstrong looking out the window. And you can see, I hope you can see on this video that there's a word that says desired site with an X. That's where Armstrong wants to land. And then he can see by looking through the window where the computer is actually taking him. And by making adjustments with the hand controller in his right hand, he can actually tell the computer to move to a different place by clicking it as many times as he wants to the left or the right or front or back. If he wants to land further downrange than the computer is sending him or further uprange, he can tell the computer to do that. So this gives you an idea, I hope this gives you an idea of how complicated and demanding the lunar landing was going to be. And of course the computer was great, but the simulator was great, but you needed to have way of really feeling what that lunar module was going to be like to fly. And for that, they used this special craft called the Lunar Landing Training Vehicle. Let's take a look at what it looks like when it's flying. It uses a jet engine to support 5/6 of its weight and a rocket engine to support the remaining 1/6. And with that arrangement, it flies just as if it were flying over the moon in the moon's 1/6 gravity. And here you see Armstrong, probably Armstrong, setting it down onto a runway at the Air Force Base near the Space Center. Now, an earlier version, Armstrong had to bail out because it went out of control. And here you see that accident. This was actually more than a year before Apollo 11, but it gives you an idea of the danger in flying that lunar landing training vehicle, and yet it was essential preparation for all the guys who landed on the moon.